YouTube channel. This is Jonathan Goldfish. Be sure to like, share, and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back to this YouTube channel. This is Jonathan Goldfish. In the previous chapter, in the previous video, we are discussing about the coordinate geometry. Alright, for this video today, we are entering the new chapter, new and shortest topics among the pure mathematics one, which is the chapter 4 circular measure. Okay, this is also a geometric chapter, but this geometry is for a circle only because this chapter says circular measure. Okay, you need to see the word of circular, then you need to think about a circle. Okay, so before I entering these fellow topics, I need to go through this circle with you, okay, and their properties. So first, given there's a circle, okay, so this arc length, the curvature of the circle, for a part, we can call it as arc, okay, arc of the part, okay. So its perimeter, we call it as arc length. We will discuss this later for the formula to find the arc length. Okay? If your arc length of the circle occupies the entire circle, what does it call? It calls circumference. Okay? So circumference is the perimeter of entire circle. Okay? Which rotates 360 degree. Alright, so in this circle, one property you must know, that is the radius of the circle. Okay, so radius of the circle is the distance between the center to the point of contact with the arc of the circle. Okay, and what is diameter? Diameter is a line between the two arcs that intersects with the two points with the arc where it intersects with the center. Okay, but for the chord it's different. Although it also intersects 2 points with the arc, however, it does not touch the center of the circle. We call it as chord. Alright, so for a region that is bounded by the two radius and one arc, okay, of course it touches the center of the circle, we call it as sector. Alright, for the region which is only bounded by the chord and the segment, we call it as the arch, we call it as the segment. Okay, that's the end of the discussion about the properties of the circle. Okay, there's another thing you should know, that is the diameter is the twice of the radius. Okay, this one you should get to familiarize from your secondary school. Alright, the next thing you should know, that is the 1 radian. Okay, how to define 1 radian? 1 radian is actually angle subtended to the center of circle, where arc length is equal to the radius of circle by 1 unit, when its unit is a rad. Okay, RID, rad, represents radian. Okay, this one, although in pure mathematics 1, it doesn't want you to define what is 1 radian. However, in physics A2, you will learn this later. Okay, it is chapter 13 A2 physics, motion in a circle. Then perhaps physics wants you to define what is 1 radian. Okay, so what is the relationship between the radian and the degree? Okay, degree, your expected unit of the angle is in degree, but this time in the standard units we use radian. Okay, even trigonometry also uses the radian as the standard unit, or for the x-axis in the trigonometric functions graph. Okay, and how to convert from the degree to radian? Just multiply pi over 180 degree, and if you want to convert back from radian to degree, just swap the pi and the 180, enough. Okay, this one you can read through by yourself. I won't discuss with you further. And from the relationship on the left hand side, you can deduce that the pi rad equals to 180 degree because the ratio between of this and this must be proportion. All right. And another part is the arc length. Okay, just like what I mentioned just now. So how to find the arc length? It is a radius times the theta, where theta is the angle in radian only. Okay, please get to understand and familiarize about these two formulas. Okay, I think these two formulas you should get to know from your secondary school. Okay, just move your knowledge from your secondary school to the to here. Okay, because here is the discussion of the pure mathematics one in A level. All right, so I don't think I will derive these two formulas for you. However, if you want, you can request to me in the comment section below. All right. So how to find the area of the sector? We use A to represent area of sector. Is the half r square theta, where this theta is also in radian. Okay. So in this video, I won't discuss the derivation of these two formulas. Alright, that's the end of this subtopic and this entire chapter for circular measure. But before I proceed to the exercise, I may go through the extra information to you. So sometimes when you solving a questions that involves the circular measure, you will get a triangle. Okay? Recall that if you are given a scaling triangle inside the circle, you must use the sine rule, cosine rule, or somehow area of triangle to find the let's say angle and the sides of this triangle. Okay, somehow this triangle is not the scaling, not the right angle triangle or isosceles triangle. Okay, and I won't discuss these two for you because these two are basically from secondary school. All right, even this area of triangle also. And there's another formula to looking for the area of triangle. You may use the Heron's formula if you wish. Okay, where this S is your semi-perimeter. So how to find the semi-perimeter? I'm sorry. How to find the semi-perimeter? Just sum all the perimeters of the triangle divided by 2. Alright, I won't discuss this to you too much. So yeah, that's the end of this discussion of this chapter. So now let's proceed to the exercises before I end this video. Now is the exercise for the chapter 4 before I end this video. Alright, so let's take a look at the first question. Alright, as I mentioned from the post, I'll only discuss some of the questions with you only. Alright, the rest of the questions you need to try out by yourself. Okay, so I'll have a face review with you in the right time. Alright, and in the next video I won't gonna proceed to the chapter 5 because I want to stay back at the previous 4 chapter I taught with you. That is the full solutions of the exercises for each chapter. Alright, let's take a look at the first question. Write each of these angles in radian, correct to 3 significant figures. Alright, I need to recall the relationship with you. Alright, so how to convert the angles into the radian? Okay, so here is the angles in the degree. Okay, to convert in the radian, you just multiply by pi over 180 degree, enough. Okay, actually it comes from the ratio because the ratio are proportions. I mean the ratio of this and this are equal. Alright, so that means the relationship is proportional. Alright, so I'll only select the A and C enough. Okay, so how to convert the 28 degree into the radian form? Okay, so just 28 degree multiplied by pi divided by 180 degree. Alright, just press your calculator. 28 times pi divided by 180, what will you get? Okay, because the question wants you to live in 3 significant figures, so By right, if you use a calculator, you will get 0.487. Okay, you may check your answer and see. And let's solve the C. So C is 47 degree. To convert it, just use the same method as A. Okay, repeat the same method. Just to replace 28 by 47. So you will get 0.820. Okay. So although it has the about 0.8203047 something like that, something. Okay. However, you must live in 3 SF. Okay, because 0 can be the third SF. Alright. And the rest of the part of this question you can convert by yourself. Okay, this is as the practice. Alright, remember, practice makes perfect. Alright, for the question 2, write each of this angle in degrees correct to 1 decimal place. This time, you convert from radian to degree. Okay, so we just swap the relationship. Alright, like that. Because this pi is radian and this is radian, the unit of the radian can be cancelled. So in the final answer, you will get the degree form. Alright, so I only discussed D and E for you. And the rest of the question, you need to try out by yourself. 1.52 rad. This is the 0.79 rad. Okay, I'll solve the 1.52 first. It is basically multiplied by 180 degree divided by pi. And correct to 1 decimal place. So, by right, you should get 87.1. Why does this question want you to leave the degree form in the 1 decimal place? Because for a standard answer of the angles in degree, you must leave in 1 decimal place. Okay, as the instructions stated in your passing questions. Alright. So, carry out the same procedure for E, 0.79. Just multiply 0.79 by 180 degree divided by pi enough. Like that. Okay. So here for E you will get 45.3. Wait a second. Oh. Okay, so you have 45.3 degree. Okay. Sorry about my stylus because due to the system issues. Alright. So the rest of the part I need you to try out by yourself. Okay. So I'll clean this up to save some storage. Okay, let's take a look at the third questions. Find in terms of pi the arc length of the sector. Okay, recall the formula. What is arc length? Arc length is S equals to R theta, provided your theta must be in radian. Alright? Okay, so let's take a look at the A. Given that your radius is 8 and your angle is pi over 4 rad. Okay, pi over 4 denotes now 45 degree. Okay, you can try convert this angle to degree and see. So the question wants you to find the arc length. How to find the arc length? Just multiply 8 by pi over 4 enough. Okay, because the question wants you to leave your answer in terms of pi. So you need to leave in the exact form. Okay, the answer is 2 pi. 2 pi is equal to 360 degree. Okay, so let's take a look at the D. Alright, so for BC, you can try by yourself. So just use the S equals to R theta enough. Okay, carry out the same procedure. So for this part, your radius is 24 and the angle is 7 pi over 6. Use your calculator to calculate that your answer for D is 28 pi. Replace my answer. Yeah, to make it nicely. Okay, neat and nice. So I don't think this part is difficult for you. So why not we proceed to the challenge question. Although this is the simple one. Alright, let's jump to question 5. The diagram shows a semicircle with a radius of 10. Okay, here is the radius of this semicircle. Alright, I forgot to mention to you a sector, I mean a shape with which is bounded by the diameter and the half of the circumference, we call it as the semicircle. Okay, and the center O, okay, because the radius is the two ends of the radius is the O and the point of intersection with the arc. Okay, and the angle BOC is theta radian. So this is your theta. Okay, perimeter of the sector AOC. What is perimeter of the sector AOC? It is the sum of the arc length and two radius. Alright, so it tells you that the perimeter of AOC is twice of perimeter BOC. So what is the sum? What is the perimeter of BOC? Is the sum of this arc length and these two radius. Okay, so it's a twice of the perimeter of BOC. Okay, so I have this relationship. Alright, so for the part A, show that theta equals to pi minus 2 over 3. Okay, so you need to use the information from here to prove this result. Okay, so what is the perimeter of AOC? As I mentioned just now, it is the arc length of AC and two radius. Okay, 2r equals to twice of the perimeter of the arc length of the BC and two radius. Okay, so you may expand inside. Again, okay, I need to move above a bit. Okay, so what is the formula of this 2s? Okay, it's the r theta. Okay, so you have the r theta, r theta. Okay, and here you also have the r theta. Wait okay. So as you know that this angle something, I label it as alpha. So alpha plus theta equals to 180 degree, which is a pi. So therefore your alpha is theta minus pi minus theta. Okay, so use this relationship to substitute away the alpha. Okay, so what is the arc length of the AC? It is a r theta. Okay, so what is the arc length of BC? It's also r theta. Okay, but this is not your theta. For the arc length of AC, it is a pi minus theta. Okay, so you can see that there's a common factor of the r. You may cancel it out, and then simplify it. Then you should get the result from the question stated. Okay, I mean the answer from the question stated. So yeah, this minus theta move to there is 3 theta. Okay, and then for the 4 move to the another side is 2 minus 4 is negative 2, pi minus 2. Okay, you should get your theta ready. Oh sorry, I think here Here is something wrong, this part. So you will get theta equals to pi minus 2 divided by 3, so shown. Okay? Because for this question, it wants you to perform your workings to get the answer from the question stated. Alright? Okay, let's take a look at the B. Find the perimeter of the triangle ABC. Okay, first thing first, you need to find the uh, the chord of the BC and chord of the AC first. Okay? And yeah, for the for some of the extra topics that you need to know, that is how to find the AC, how to find the chord from the radius and the angle theta. You should use your cosine rule, right? So you have the radius, here is your perimeter of the diameter of the 20, right? And how to find the AC and the BC before I calculate the perimeter. Okay, so here you have the 10 cm and also 10 cm, that is two radius. So you should use cosine rule to find your AC and repeat the same procedure to BC as well. Alright? And yeah. So to find the AC, you should use your cosine rule, which is 10 square plus 10 square minus 2 times of the 10 and 10 cos of this and this angle alpha to get your AC. Alright? Cosine of the what is alpha? Okay, your alpha is, I think I find the BC first. Alright, because BC is easier to find. Pi over 2 minus your 3. Pi minus 2 divided by 3. Okay. Yeah, before you calculate, before using the cosine rule, please make sure that you convert this degree in the radian form. So for this, I will post the shorts for the guidance to convert from degree to radian before you use the cosine function in your calculator. Okay, because now the calculator that I'm using, that is the Casio FX570EX. Okay, so I'm gonna recheck again to confirm my answer. So for your BC is 3.7824. Okay, when your steps when your steps has the decimal accuracy value, you may leave in 5 significant figures, as this value is not your final answer. Okay, because you want to use this value carry forward to find your final answer. Okay, because this question, the final answer of this part is perimeter of the triangle. Okay, carry out the same step, just that you change this as the pi minus 2 divided by 3. Okay, to looking for the AC. So just using the cosine rule, just that your angle is different by the pi minus the theta. Okay, to looking for your AC. So over here, your AC is 90.639 in five significant figures. And finally, to find your, sorry, I think this part is malfunctioning. So to find your perimeter of the ABC, just take the sum of the 10 plus 10, or you can direct write 20 also can, because 20 is the diameter, which is twice of the radius of 10, and 3.7824 and 90.639. Finally, you can press your calculator and see. So if you use a calculator, you will obtain your final answer is approximately 43.4 as your final answer. Okay, because given that your radius is in cm, so better for you to write the perimeter in cm as well. Alright, so this is the guidance for the question 5. Alright, other than using the knowledge from the circular measure. And next I'm going to discuss the past year questions for you. Okay. Alright, so for the challenge part for question 7 is also extracted from the course book, but I don't think I will discuss this for you. You need to try out by yourself. So let's discuss the past year questions directly. So for this question 9, this is the 9709 May June 2007 question 5 paper 1. So this question gives you a diagram. Okay, so let's read through the instruction. In the diagram, OAB is a sector of the circle, this sector. Okay, with the center O, radius 12, correct, check and check. The lines AX and BX are the tangent to the circle. Yeah, so what is the tangent to the circle? This one I don't have to repeat for you. Okay, it is basically a line that intersects with only with one point with the curvature of the circle, where it is perpendicular to the radius of the circle. Alright, and lines AX and BX are tangent to the circle at the point A and B respectively, and it also gives you the angle AOB is pi over 3 radians. So for the first part, find the exact length of the AX, giving your answer in terms of cert 3. This question is indeed interesting. Alright, give me some time, I need some preparation for. Alright. There it is. So for the first part, how to carry out the steps that leads to the answer in exact form. Okay. So first thing first, you need to find the angle of the. Yes. So for this part, this angle and this angle is confirmed 90 degree because these two lines are tangent to the curve of the circle. Alright. As I mentioned, what is the tangent to the circle? Alright. So okay, what are you going to do? You just cut with a line to separate to half. Okay, so if I cut using this blue line to separate into the half, you will see a right angle triangle over here. Okay, then the question wants you to find the exact length of the AX. So how to find? Okay, as you know, here this angle is pi over 3, therefore your angle for here is pi over pi over 6 because pi over 3 divided by 2, correct? So here is a pi over 6 rod. And also OA is your radius, which is the 12 cm. And I want to find the AX. Okay, so to find the AX, you just use the trigonometric relation, which is your torcastle. Okay, if you still remember the relationship of the torcastle, which is the trigonometric ratios, so this is your adjacent, this is your angle. So you need to use the relationship of tangent because you want to find you want to find the opposite, but you only given an adjacent and the angle. So you must have tangent. Okay, so tangent pi over 6 equals to ax over 12. Alright, it is better for you to memorize all the exact value for the certain degrees. This one I will cover with you in the next chapter. But the next video is not entering the next chapter. I mean not move on to the next chapter, because the next video is for the solutions for the exercise for each chapter. Okay, so to find your AX, it is the 12 times tangent pi over 6. Alright, so use your calculator to calculate the exact value of the tangent. So first calculate the exact value of the tangent from your calculator, or you can memorize. So you will have 12 times sec 3 over 3, or 1 over sec 3. Okay, but the question wants you to leave your answer in the terms of sec 3. So 12 over 3 you may cancel out. That means your exact length of the AX is 4 sec 3. It is better for you to write cm. Yeah, this is how you find the exact length of the AX. Alright, 4 sec 3. Okay, for the next part, find the area of the shaded region. So how to find the area of the shaded region? How? Okay, so since these two triangles are congruent, okay, why do I say congruent? Because the size are the same and proportion with the ratio of 1. This side are equal, and also equal degree, equal hypotenuse, and equal adjacent. Alright, so these two triangles are identical, congruent and identical. Alright, so to find the area of the shaded region, I need to calculate the area of this entire geometry. Okay, minus the area of this entire sector. Okay, this is the way you are thinking. Okay, you can solve the area of the shaded region in this way. Alright, you can write A of the shaded region, that denotes the area of shaded region, that is the area of all, or I can write OAXB, minus the area of the sector OAB. So this the area of the OAXB is this entire geometry, that is twice of half times 12 times 4 sec 3. Okay, because the area of a triangle is the half times base times height. Okay, and since the another triangle is identical with this, just times 2. Alright, so actually if you modify this and this, you will form a rectangle. So it is basically 12 times the 4 sec 3 enough. Okay, so let's take a look at how to find the area of sector. It is a half r squared theta. So I have half, what is the radius? 12 square. What is your theta? Pi over 3, because I want to find the area of sector of this entire sector, okay, where the angle is pi over 3 rad. I think this below part has a problem of the context sensitivity. So I will move upwards. So these two you may cancel out. So what will we get for the left term? You will get 48 sub 3. Okay, for the right term, you may calculate and see. You will get 24 pi. Alright, your final answer of the area of the shaded region is 48 sub 3 minus 24 pi, because the question wants you to leave your answer in terms of the pi and sub 3. Yeah, if you do in this way, congratulations, you are successfully answered this correctly. Okay, because you leave your answer in the sub 3 and the pi. So this will be your answer, cm squared. Okay. So this is the way how you answer this question. This question is quite direct, and there's another question is quite challenging. Okay. So let's take a look at another partial. This is the partial question 12. This partial is from 9709 May-June 2009. Question 5, paper 1. Okay. So this question also gives you a diagram. The diagram shows a circle with the center O. Okay. The circle is divided into two regions. Okay, two regions means two different sectors. Alright. By the radii. Okay. Radii is another term of the radius. Okay. Radii is the plural, whereas radius is singular. Alright. So OA and OB are the radii, where angle AOB equals to pi radians. The perimeter of the R1, okay, what is the perimeter of the region R1? It is the arc length AB and two radii, which is equal to the length of the major arch. Okay, it means that this perimeter equals to the arc length of this. Alright, so for the first part, show that theta equals to pi minus 1. So usually for the first part, you need to use the information and relationship from this sentence. Okay, so let's solve the first part. Okay, so let R is your OA and also OB, correct? Okay, it says that the perimeter of the R1 is the arc length AB. Okay, use the formula of the arc length S equals to R theta, so I can label R, but this theta is not, this angle is not theta, it's 2 pi minus theta, because 2 pi is like 360 degree. Alright, so for the angle you write 2 pi minus theta. For the perimeter, it is the sum of the arc length AB and 2R. Okay, what is the arc length of AB? Is R theta only. Okay, for the both sides of this equation, you have the R as a common factor, just cancel out. So now you left theta plus 2 equals to 2 pi 2 pi minus theta. Okay, so move your 2 to the other, sorry, I want to use this one. Move your 2 to the right hand side and this to the left hand side. So you have 2 theta equals to 2 pi minus 2. So you can also see the 2 is the common factor. Factorize the 2 for the on the right hand side equation, cancel the 2, and so the equation is shown. So if you've done this part, you have successfully shown that the theta equals to pi minus 1. Alright? Okay, let's take a look at the second part. Given that the area of the region 1 is 30 cm cube, okay, and find the area for the region 2 correct to 3 significant figures. So what is the formula of the area of the sector for the region 1? It is the A equals to half r squared theta. Okay, but this question does not give you the radius and also the theta and the theta either. Alright, you can only use, oh yeah, theta is already give you, is pi minus 1, right? Just that you only want to find the radius. But for me, this time the radius I will only leave in the exact form, okay, to make sure my answer is accurate. So the area for the region 1 is 30. Okay, here is your 30. Yeah. My R, don't know. Okay, theta is pi minus 1. So for the R, you will have 30 times 260 and pi minus 1 and get the surd. So your radius is in the surd form. Again, I think I need to clean the screen of my tablet already. So you will get the radius of surd 60 minus pi minus 1. Alright? So if you use your calculator to evaluate the decimal value of the radius, you should get about 5.2931 cm. But I don't think I will evaluate out the decimal value of the radius for the accuracy. Alright? So the question wants you to find the area of the region 2. So to find the area of region 2, just use back the formula of A equals to half r squared theta. Okay, just that the radius is always the same, but for the theta of the region 2, just 2 pi minus 1. Okay, so what is the R? Is 60 over pi minus 1. Okay, because this R is in surd form, if you square it up, you can cancel the square root and the square. Alright, for the theta, you will have 2 pi minus 1. Okay, so the question wants you to leave your answer in 3 significant figures, means that your answer must be in decimal. So just only use your calculator to calculate your area exactly. Okay, your final answer should be 58.0 because the question wants you to leave your answer in 3 significant figures. Alright, so you'll get it 58.0 cm cube. Alright, okay, let's proceed to the question 14. The diagram shows a rhombus ABCD. Okay, about the properties of the rhombus, I've discussed with you in the previous video. Okay, points P and Q lie on the diagonal of the AC, such that BPD is an arc of a circle with a center C, and BQD is an arc of a circle with the center A fundamentally. Okay, each side of the rhombus has 5 cm. Okay, means that for a rhombus, here is a 5, 5, 5, 5. So this is the property of the rhombus with each equal side. Alright, and the angle BAD is 1.2 rad. So it means that here is a 1.2 rad. Oh, I forgot to mention that this is the past year questions of the 9709 October November 2010 question 8 paper 1-3. Okay, so to find the area of the shaded region BPDQ. So firstly, you can focus your art first, and also you can separate into half like that. Okay, I forgot to recall how to find the area of the segment. All right, to find the area of a segment, you may use the formula of A equals to half r square theta minus sine theta. Okay, because this formula of the area of the segment is derived from original area of the sector and also the area of a triangle from the sine in terms of sine. All right, so for derivation of this part, I will post in shorts. Okay, for the A, you just use this formula to find out what is the area of shaded region BPDQ. Okay, if you cut a half of this region by using the blue line, you will see that two segments are identical. All right, so what is the area of the BPDQ? Is the twice of the area of a segment. Okay, segment DQB. All right, so what is your R? The R is 5. Okay, this is your radius. What is your theta? 1.2 minus sine 1.2. Okay, so please make sure that when you calculate the sine 1.2, you must convert this into the radian because 1.2 is in radian. Alright, so the steps are simple. Okay, so by right, your answer should be wait, yeah. Should be 6.70, correct? Live in 3 significant figures. Okay. Alright, let's take a look at the second part. Second part, find the length of PQ. Okay, so how to find the length of PQ? So first thing first, I want to find the chord of the circle. The chord of the circle or the length of the BD. So how to find the length of BD? You can use the cosine rule. Okay, this which is the BD square equals to 2R. Okay, so generally to find what is the perimeter of the segment, what is the perimeter of a chord? Okay, perimeter of the chord is the square root of the 2R square minus 2R square and cosine of the angle theta. Okay, this is the general term. So for me, I'll directly use the formula stated is the square root of what is the R? 5. Okay, minus 2 5 square and cos 1.2 a 5 square and cosine 1.2 to get your exact value of the BD first. I don't think it is possible to leave it exactly the same. So instead, I will only leave in decimal form. So by right, you will get 5.6464 cm. Okay, you find the length of the BD or the perimeter of a chord Okay, the chord of the circle. Next, I want to find the diagonal of the AC. So how to find the diagonal of the AC? Okay, so okay, eventually the question wants you to find the PQ. All right. So to find your AC, what are you going to do is to, okay, so separate this into the half, correct? Means that here is your 0.6 rad, here is your 90 degree or pi over 2. Okay, so that means here is your pi over 2 minus 0.6, correct? So the let me find this length first. Okay, so for this diagonal, they are bisect each other. So where this intersection, where this is the midpoint of this rhombus, all right, means that these two sides are equal in length. So our let's find the AC first, which is the twice of this length. Okay, to find this length, I can use the square root of phi square. Okay, we can use the Pythagoras theorem to do it, or you can use the trigonometric relationship, also acceptable. Okay, so this is the Pythagoras theorem. I want to let this phi square minus this, the length of this square, and and then square root it to get this length, and then twice it to get this, to get the length of this. All right. Of course, for a rhombus, two diagonals are not equal in length. Okay. So yeah. So by right, your length of AC is 8.2534 in 5 significant figures. Okay. And what is the next step? Yeah, the next step is I want to find the AP. Okay, I want to find this length. Just now I found this length. I'm sorry. I find this length first and then the twice. Okay. And how to find the AP? Alright, as you know, this is the radius of 5. Therefore, this PC is also 5 because PC is also a radius. Alright, so to find the AP, I want to find this length right now is to get 8.2534 is the length of the diagonal of this entire AC. I mean the diagonal of AC is 8.2534 minus the 5. Minus the radius lah. Okay. So by right you should have 3.2534 cm. Okay. Next step, I would like to what is the chart of the PD? Yes, because I want to find I want to find this length. Because this length and this length are equal, and I want to draw a diagonal line again over here, means that I want to find the chord of the PD, sorry. Alright, to find the chord of the PD, you carry out you need to use the cosine rule. Alright, I think I have insufficient space already. I need to create a new page. Right, so the chord of the PD is to use the cosine rule by the square root of a As you know the length of the AP and the radius AD, you just use the cosine rule. But this time these two lengths are different. So you square 3.2534 square plus 5 square minus the twice of the 3.2534, 5, and cosine 0.6. Why? We need to find the length of PD or the chord of the PD following this arc PD, okay, with respective to this angle 0.6, which is the half of 1.2. And then use your calculator to calculate that your chord of PD is 2.955. Yeah. 2.9552 is an accurate one. Is for the accurate one. Okay? cm. And finally, to find the length of this, which is the half of your answer. Okay? But for me, I want to find the answer of the PQ directly right now. So to find the PQ, you need to find the twice of the Pythagoras theorem relationship. So here is your right angle. You have the hypotenuse. You have the adjacent. I want to find the opposite easily and take this opposite. Twice of this opposite is your answer for the length of the PQ. Alright? So use the Pythagoras theorem to find the half of PQ and then multiply by 2 to obtain your PQ. Wow. Okay, we are almost there. So your PD is 2.9552 square minus the half of the 5.6464. It's over here. Okay? 5.6464 divided by 2. And finally, you'll obtain the answer of 1.75 cm as your final answer for the length of PQ. That's all for this question. Okay? I know this question is very complicated to you, but you must try your best to complete this question. Okay? If you are not able to score these 4 marks, at least you need to score these marks. Alright? It is impossible for you to score nothing for these parts either. Alright? So always hear my advice. Practice makes perfect. Okay? And also learn from your mistakes in every lessons. Alright? I declare that this chapter has ended, circular measure. So in the next video, I won't enter the chapter 5 trigonometric functions because for the next video, I'll post the solutions for the exercises for chapter 1 to chapter 4. Okay, include the discussion of this chapter just now. Alright, so let's take this video to the end by the summary of the chapter. Alright, here is a summary of this chapter 4 circle measure. Okay, so basically, you need to know all the properties of the circle, including the parts, like arc, segment, chord, center, diameter, radius, sector, circumference. And then you need to know this relationship, and the deduction of the pi rad equals to 180 degree. And also you need to know how to use the formula of arc length and area of the sector, provided that your theta is angle in radian. Alright? And finally, you need to move your prerequisite topics from secondary school inside this actual topic in this pure mathematics 1 A level. Alright, it comes to the end of this video. So in the next video, I'm going to post the solutions of the exercises from chapter 1 to chapter 4. Okay, so someday I will continue the syllabus of the pure mathematics 1 in the next year. Alright? Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.